So we have Harald Uhlig next, the University of Chicago.
Okay, I'm very glad to be here. My plane landed very late yesterday, so I hope I get to be informed what happened yesterday. It was a great conference, apparently, so far. But here I am, so thank you. I'm going to talk about this topic. And in fact, the way I thought about the topic is as follows. I wanted to raise some challenges that the DSGE literature has encountered. Some of the challenges you will recognize from things that people have said earlier today, for sure. And then discuss what has happened with these challenges in the DSGE literature. I'm going to argue not very much. Now that's a dangerous thing to do because I can see already that there's a bunch of people in the room here that will say, no, wait a second, you've just ignored my own research. And that's fine. Then just think of this talk as advertisement for your own research, because maybe people haven't paid enough attention to your research in those circumstances. Or maybe the charge is that I haven't paid enough attention to your research, in which case I apologize. So let me just move into this here right away. The quantitative DSGE models were meant to rise to the critique by Bob Lucas that it's not good to write down models with reduced form parameters or with econometrically estimated parameters, that we should write down microfounded models with deep parameters so that we can then use them to think about policy changes where these parameters would remain unchanged. And I think it has been largely successful, and I could be standing here, presenting another victory lap and telling everyone how well we have done, and I think it's true to a large extent. These models certainly are a success, but challenges remain. Initially, when I constructed these slides, I had a lot more, so eventually I decided to just stop at these 4, so there are obviously more, but let me do these here, and I think they fit with the theme of the conference. So first, let me talk about asset prices and yield spreads. One has to think they're probably central to thinking about monetary policy, yet they're typically either ignored or trivialized in quantitative DSGE modeling. Second, financial frictions. Much progress has been made in the recent literature on financial frictions. We have been taking them a lot more seriously since the financial crisis, for sure. But often these contracts are not necessarily privately optimal. And that raises thorny issues once you start thinking about policy. In essence, that's a version of the original command of Bob Lucas to think about things that don't change once you change policy. Inflation. I'm going to argue that there may be not a Phillips curve in the data. I'm going to show you 2 pictures on that, and then the econometricians will jump on that, but let me show you these pictures at least. And furthermore, the quantitative DSGE models may do a fairly lousy job of accounting for inflation in terms of monetary policy shocks. Monetary policy shocks seem to have very little to do with inflation, potentially, and if they're guidance for monetary policy, that should give us some pause. Finally, Marty already talked about the neo-Fisherian features of the new Keynesian models, and I know that John has been harping on that also. They're a lot stronger than I don't know, people generally recognize. I think people inside the literature probably know that, but it's only when you start playing with that and looking at them that you realize this. So I think they've been swept under the rug a little bit. I'm going to talk about this. Okay, so let me jump right in. Let me talk about asset prices first. So here's first a challenge to anybody thinking about theorizing about asset pricing, which is the following. Take any log linearized solution, let's say for consumption and returns. And I'm going to say in a log linearized world, I'm going to stay with separate preferences for now. You could make this all more general, but I think this example here will suffice. So then, log consumption, log returns will feed back on some state, ST, let's say, with some linear coefficient, and then there will be shock. Some surprise that's a date t+1 surprise at that time, and then you turn to the Lucas asset pricing equation, which is here, and you plug in your log linearized consumption and return evolution, and then you get to the second equation. So I think there's full consensus. If you have log preferences, so there's here for log preferences, there's full consensus that that's what we would end up with. So now you have to calculate this condition expectation. And suppose that the error term there, the sum of the nu t+1 minus the epsilon t+1 is normally distributed with some variance. Maybe the variance is even moving over time. Then you can calculate that expectation, right? That expectation will be the e to the variance half. And then you can use that formula and to I don't know, think about Sharpe ratios and risk premia and all kinds of things. And there's a large literature doing that. But what if that difference between ut plus 1 epsilon t plus 1 is not normally distributed, but instead t distributed with, say, 1,000 degrees of freedom, same variance? If you try to do a plot of the two, you couldn't notice a difference. They are practically observationally equivalent. Yet if you put a t distribution there in this expectation, because t distributions don't have finite moments, eventually, that expectation is now infinite. So you get suddenly this whole range between e to the sigma squared half and infinite as a result here for distributions that are looking very much alike. And that means you can kind of do everything that you want. And that's a conundrum. And now what, right? I think people tend to ignore it. I'm going to ignore it too and just move on. So it used to be a challenge to get equity premium, reasonable equity premium inside DSGE models. Nowadays, there are a variety of approaches. I see Rob Barrow was done disaster risk. There are others, habit formation. So let me run with one that's very, very popular, which are these Epstein-Zinn preferences. And they're great. They're used a lot in the finance literature to think about asset pricing. Now, again, you can put them in a DSGE model, and they're not harder than any other preferences. You get some equations, and you can log linearize them again. I like log linearization because it gives me a start on how to think about issues. Okay, so up there is the log linearized version of the value function that comes out from Epstein and Zinn. And it has this consumption term in there, and then it has this R hat term in there. R hat are these distorted expectations that come out of Epstein-Zinn. And these distorted expectations are the expectation of the future value. And when you then all put it together, the stochastic discount factor log linearized is this m hat t plus 1, and it will involve this change in consumption, the change in consumption if you assume that the intertemporal elasticity of substitution is 1, and then a term that scales this difference between the realization in the v hat t plus 1 and the expectation r hat time t, and it scales it essentially with this risk aversion coefficient. So by scaling eta up and down, you can get huge risk premium, if you like, if you live in this log linearized normal distribution world that I now want to think about. So this you can just add this to any DSGE model. But when you then think about allocations, all that we need for thinking about allocations in these RBC models is the next equation. We just, in these equations in log linearized version, all that shows up is the expected stochastic discount factor. And now this difference between the v hat t plus 1 and the r hat t disappears. So what that means is that if you put Epstein-Zinn preferences into any DSGE model, which is really easy to do, I mean, this is route to do it, it turns out that there's a dichotomy, at least up to first order, between the risk pricing and the allocation in the economy. There's no connection. You can get risk prices, great, but they don't influence what's happening in the real economy. To me, that's a little bit too easy, right? Now we have kind of solved the first problem, but there's clearly something else that needs to show up. Okay, finally, let me point this out here. If you think about asset price, 10-year yield spreads, for example, right? Maybe investors care about what the 10-year rates are, yet the monetary policy is moving the short rate. And you can have these plots, and then you can think about the relationship, right? And there's many tests in the literature that have shown that the simple expectation theory between these types of yields doesn't hold. So it's a crucial element to thinking about monetary policy. Yet in the typical DSGE models, it's not treated like that. It's ignored. Typically, if you have it at all, we typically think of these as just satisfying the expectations theory. There's some, people have been working on this, but it's not entered the mainstream yet. Okay, so the bottom line here for the asset pricing part is they're probably central for monetary policy, but typically ignored in these quantitative DSGE models. Let me talk about financial frictions. And here, it's hard to think about monetary policy without thinking about either pricing frictions or financial frictions. And there has been great progress in the recent literature, thinking about financial frictions. I'm going to run after these two models here because because I admire them. They've become very much the benchmark of the workhorse models of large parts of the macroeconomic profession, wanting to think about some kind of financial friction in the economy. There are other approaches for sure, but those are maybe the key main workhorses. There are the Hank models, the heterogeneous agent, Keynesian models, sorry, and there are these financial intermediary models with banks, in particular Gertler, Kowalski, Otaki, or GKK. And they're wonderful model. But they're also increasingly used to policy guidance and welfare analysis. And then you want to be careful because you have to argue that things that policy addresses can't be addressed by the private agents themselves. You're running into what I'm going to call the chicken paper conundrum. And the chicken paper is attributed by anybody who studied Minnesota to Ed Prescott, and it's a caricature of a paper. So it sounds funny, but it should be taken very seriously, I think, in advertising models as being useful for policy analysis. So chicken paper analysis, chicken paper, according to Ed Prescott, runs as follows. You're making 3 assumptions. Assumption 1, households enjoy consuming chicken. Assumption 2, households cannot produce chicken. Assumption 3, governments can produce chicken. Conclusion, government should produce chicken. And it seems like easy to come from assumption to conclusions, but once you see this line of argument, you see this in lots of papers. I'm not necessarily saying it's bad, right? But if you write a chicken paper, be open about it. And if you don't want to write a chicken paper, think about things that agents might do, possibly to try to produce chicken themselves. So, Hank, for example, the famous, the Hank model or the IRGR model that analyzes it. Well, if income fluctuations of agents are known, why not write full insurance markets? There's probably some underlying friction in the models that prevents that from happening, but they're typically not spelled out. GKK, if we worry about net worth being destroyed in recession of banks, why don't we write insurance contracts and have banks insure themselves against this? There's a variety of other things you could think about once you put fluctuations into models there. So what we need a DSGE model with privately optimal, fully optimal long-term contracts. So I'm giving you one, right? I don't want to say just, negative things here, so I'm going to, advertise my own work, I suppose, Okay, so think of a continuous time IRGARI model, where as an IRGARI, agents have these idiosyncratic income fluctuations. So they have this Markov process where the income may be either high or maybe zero. And there's some transition rates here going from high to zero and from zero back to high. There's an aggregate production function, which is just a standard Cobb-Douglas production function, and capital depreciates at some rate delta. Agents discount the future with some rate rho, and there's going to be an equilibrium interest rate R that we'd have to solve for. We are assuming now, in contrast to the literature, that agents enter long-term contracts. So we are taking the contracting friction seriously. We write down a friction and then say, that's a fundamental friction. What's the best thing that agents can do? And what we assume is that they're competitive intermediaries that commit long-term. These could be firms, right? And these agents could be workers. But workers can quit their job at any time and walk off to the next firm if they feel like they can get a better deal at the next firm. So the firms might supply the workers with some insurance, but the workers can't commit to doing their part, forever in return. There's full information, no credit history, punishment. Now what you get when you start thinking about it is that the contracts are front-loaded, the payments from the intermediary are back-loaded. We got some results for steady-state comparisons. So this is just advertisement for this work. I'm just going to give you a little bit of a taste of what's happening. So here's how the contracts look like. So this is for random fluctuation in income. Here actually the income is not at zero for this picture, but that doesn't matter very much. So in these optimal contracts, consumption is high and constant if you're in the high income state, and if you're in low income state, it starts declining. If you have positive income here, it will eventually hit some lower bound, but otherwise it will just keep declining forever. And then you can solve this in closed form. From there, you can solve in closed form for the resulting consumption distribution. So here's some examples for the densities that result, and from there you can calculate equilibrium. So I'm just going to show you these pictures just to say we can, right? They're not, it's still very much at the beginning. I think of us as being at the stage that Ayagari maybe was in, when he published his paper, but look what became from that literature. So we're hoping this could be competitive in the future. And there are many more ways to do this. So, if you want to get on the bandwagon here and do something along those lines, the more the merrier. Okay, so much progress has been made. These contracts in the literature are often privately not optimal. We may then run into this chicken paper conundrum, and I think we can solve it. Let me talk about inflation. So here's a Phillips curve, and if inflation is high, unemployment is low. If inflation is low, unemployment is high. Well, that Phillips curve was generated in my laptop, so I just artificially generated some data, right? I just assumed some equation, and then I just did a scatter plot. Wouldn't it be nice if the data looked like that? It's this Phillips curve that's in all the central bankers' mind. This kind of picture, and it's in the minds of many of us. Let's face it, right? I mean, that's the textbooks that we grew up upon. How does a Phillips curve look like in the data? Well, if you take data from 1948 to 2016, just taking the unemployment rate and inflation in the United States and plot them, this is what you're getting. You're getting a Phillips cloud. In fact, if you put a regression line, they even slope the wrong way, depending on which regression. I mean, you pick what you want to choose on the left-hand side here. There are two regression lines now. Now, the new Keynesians will accuse me of not looking at the right Phillips curve, right? Because that's not the Phillips curve that they're using. They're using a different one. So here's the Phillips curve that they're using. They're using it down here. They're using that inflation today is essentially expected inflation tomorrow plus kappa times the output gap. So I'm going to rewrite this by moving inflation tomorrow to the left-hand side and removing the expectation operator. So that then gives me an error term that shows up on the right-hand side of the equation. And instead of using the output gap, I'm using the negative of the unemployment rate. So then you turn the new Keynesian Phillips curve into it's now I can use the same data as I did before. Okay, so here it is, right? So that's the new Keynesian Phillips curve. If you do it, monthly data, I admit, right? So this is like a first pass at the data, and you don't see a systematic relationship, I would argue, between unemployment and this new Keynesian Phillips curve residual here. Now, if you have a lot of fantasy, maybe there are Phillips curves. Right? If you torture it enough with enough econometrics or do the right sample, maybe there are Phillips curve. But if someone had published this in the AR, and said there's a systematic relationship, now that will be hard to publish these days. But Phillips managed to publish it back then. But things have changed. Okay, so now the flip side of this is if you look at the DSGE models, they have a hard time accounting for inflation using these Phillips curve mechanics, using monetary policy shocks and using the real shocks in the economy. So just for fun, we took the Smets-Wouters 2007 model because it wasn't tainted by the crisis. The Smets-Wouters model is a version of the Christiano-Eigenbaum-Evans model, but it's a Smets-Wouters model that has become very popular among central banks as a workhorse model for thinking about monetary policy. And we just took that, and the model automatically accounts for how inflation moves. So we said, let's just ask the model, how did inflation move and why, over the sample. So this is what we're getting. The blue line, I forgot which one is which. No, I think the blue line is actual inflation. And the red line that pretty much covers is the contribution just by price and wage markup shocks. So what are price and wage markup shocks in the model? They're models that say firms raise prices just because they feel like it. And wage markup shocks are shocks to wages, where wages are risen just because workers feel like it or firms feel like it. No fundamental reason. They're just there to complete the equations. So inflation dances to its own music, and you can also so that also shows up in the variance decomposition. Essentially, all of inflation movements are driven by these price and wage markup shocks, and they're driven very little by anything else. For example, monetary policy shock only contributed 6% here. And you can also check that these shocks don't do much on the real side. Now, Ben has this wonderful quote in the Carnegie-Rochester paper where he says, well, just the fact that monetary policy shocks haven't contributed to movements in output, I think at the time you said, doesn't mean they couldn't be important, right? It's the same thing as with atomic weapons. Just because atomic weapons haven't contributed to movements in output doesn't mean they could if they were to be used, right? And so maybe this is just because monetary policy shocks were small in the models. But that's really not what's happening. These models typically get quite sizable movements in monetary policy shocks. So there's a disconnect here. There's a disconnect. In fact, the only time when they do matter is this time. That's where they have a connection. During the recent crisis, you had a connection between real shocks in the economy, monetary policy shocks, and inflation movements. Just at the time when people thought there is little connection, turns out the connection is somewhat greater. Okay. So bottom line is the data, maybe there is no Phillips curve. Maybe we should just say goodbye, call it a Phillips cloud. Quantitative DSGE models don't seem to account for monetary policy shocks through inflation. And so maybe that suggests that these new Keynesian and Phillips curve-based new Keynesian DSGE models have provided poor guidance for monetary policy. Fifth point is the neo-Fisherian feature of new Keynesian models. I guess I got alerted to this by John here. So then you start playing on this with your computer. So I'm just going to take this three equation, the standard three equation you Keynesian model. That's just textbook. That's just straight out of, Girdler, Gali's textbook, whatever. I mean, you find in lots of places, right? So you have the IS equation that relates the current output gap to the future expected output gap, plus this plus the surprise in plus the real rate essentially, or minus the real rate. You have the Phillips curve that relates inflation to expected future inflation plus kappa times the output gap, and you have the Taylor rule, named after John Taylor. Now, I notice there are lots of smart people in the room, so they might say, wait a second, there are 4 equations, not 3. And that's correct. The fourth equation is just specifying what happens to the error term in the monetary policy. Right? It's not a really substantial part, but we should have that too. So the only thing that allowed myself here, but I don't think that's out of the spirit, is to make that a little bit persistent. Normally, when you have a monetary policy shock, we don't think of this dying down right away, but it may take a while. So then I pick parameters. I think these parameters are largely uncontroversial. Oh, I have another 5 minutes. That's cool. Probably I finish early. Even I shouldn't say that. Okay. So you have I pick psi equals 0.1. Maybe that's the only problematic parameter, but I think otherwise they're fine. The phi, that's a feedback term on inflation that John emphasized so much, satisfies the Taylor principle that's larger than 1, for example. And so now let's check some impulse responses to an expansionary monetary policy shock. So what's an expansionary monetary policy shock? Epsilon minus 1, so you want to lower interest rate. That's the origin of the movements now. And then let's trace out what happens to the system. And I'm going to do this for 2 settings of my persistence parameter. So first I'm going to do 0.4 and then I'm going to do 0.6. So when you do 0.4, then you're seeing, what maybe Friedman had in mind, according to Marty, if I understand this right. Maybe inflation reacts a little bit more strongly here, but you're lowering nominal interest rate, and lo and behold, the output gap improves, right? So you're having output booms essentially, but inflation picks up too. And then in this model, there's not a lot of persistence, so things die down over time. Well, now let's improve psi to 0.6. Now the impulse responses look like this. They haven't changed much for output inflation, but now nominal interest rates move up rather than go down. And essentially what happens, so I think, Ben Bernanke would have been good in explaining this if he ever wanted to. I don't know whether he would have dared to do this, but he would be the only central banker that I would trust explaining this. So he would essentially have to go to the press after the FOMC meeting and say the following, in 2009, let's say, 2010, pick your year. He would have said, we think the economy is in doldrums, inflation is too low for our taste, output is too low for our taste, we have decided to cut nominal interest rates. And then somebody in the press would have raised his hand, but Mr. Chairman, you had this GR lower bound. Interest rates are 0. How are you going to cut interest rates? And then Ben Bernanke would have said, well, we're going to lower interest rates for a while. Right? That's a persistence parameter. We have decided to expand persistence to 0.6. And mind you, these are quarters. This is not a very persistent shock. And then the journalist would have said, but Mr. Chairman, how is that going to solve the problem? And then Ben Bernanke would have explained, or would have had to explain, if that was the logic on which you wanted to base that policy. He would have said, well, as it turns out, when we do this for a while, output and inflation in the future are going to rise. Because we live in a world where people take expectation, they take that into account currently. So that means inflation, the output gap, rises today. The Taylor rule asks us to respond to that, so we have to raise interest rates as a result. And so we get this happy union where, by cutting interest rates, we end up raising interest rates as a result and stimulating the economy at the same time. Now, maybe it's true, maybe that's a bug, maybe that's a feature. If that's true, that's wonderful. So maybe you shouldn't have fretted about the zero low bound all that much. But I want to throw that as a challenge to either central bankers to run with that explanation, or as a challenge to DSGE theorists to think about this a little bit more. By the way, in Marty's pictures, you also saw that inflation was pretty flat. So he talked about the Fisher-Arian features in the DSGE model. So it's not in contrast here to what the things that Marty has said. It's just that we don't advertise these implications of our theory that much. So there's literature that's now developing on these Fisher-Arian features, and they're pretty substantial, right? They rise sort of in a very simple manner. Does that then mean that these models are a reliable guide for monetary policy? Well, take your pick. I'm sort of somewhat skeptical. All right, let me conclude then. quantitative DSG models, I'm just going to repeat the first slide, right? So the idea is I'm going to say it and then say it again and then say it a third time. So I'm just going to repeat myself. So quantitative DSG models were meant to rise to the Lucas challenge of finding microfounded models with deep parameters in which we can do monetary policy analysis. But then challenges remain. On the asset price and yield side, they're important for monetary policy, yet they seem to be largely ignored in the quantitative DSG models. On the financial frictions, we have made much progress, but oftentimes we may not think hard enough about making sure that these contracts in these DSG models are privately optimal, so that gives room for private markets to respond to these frictions themselves rather than leaving it all to policy. Or we have to argue why they don't, right? So that's a conundrum. Inflation, there may not be a Phillips curve, and the quantitative DSG models attribute little inflation to monetary policy shocks, and new Keynesian models have strong neo-Fisherian features. Thank you very much.